Okay, welcome everybody back to physical science. This is where we ended up yesterday. We were talking about Boyle's law, and we were talking about the syringes that we were all playing with. And now we're going to talk about the math that you will need to know for the test. Okay, so we're going to have, we're going to have 4 equations for sure on the test that you need to know. Pressure equals force per area was the first one. But this is the next one here. We just talked about the pressure equals force per area yesterday too. But under Boyle's law then, and we talked about yesterday, if we have a fixed gas, which means we do not add any more gas to it, and we decrease the volume of that gas, its pressure is higher because there's less space for the particles to move in. Well, if there's no change in heat, which would be the absolute energy of the particles, or if you're talking the average kinetic energy of the particles, the temperature, if there's no change in that, then if you have less space to travel across before you hit something, then it'll take less time to travel. And so this added pressure comes from this added collisions, because there's just less space to move around. So here's the question. Problem example. So right here. Problem example. If the pressure on 2 liters of a gas at normal atmospheric pressure, which we can say normal atmospheric pressure is 760 millimeters of mercury, was increased to 520 millimeters of mercury, and that's because we measured this with a column of mercury. What would the final volume of the gas be? Okay, so this is the equation. Okay, P1 times V1 equals P2 times V2, and so that means pressure 1, or the first pressure, multiplied by the volume at the first volume is equal to the multiplication of the pressure at the second volume and the volume at that. So let's say that we have, put a picture here. Here's a gas, it has a volume, and it has a pressure. So the particles inside are applying a pressure because it hit constant collisions. If I shrink this cube down, what's going to happen to the pressure? Just without even doing the math, smaller cube, no gas has been put in or out, what's going to happen to the pressure? It's going to increase because they're going to hit more often, right? So this then would be like, let's just say that I have 760 millimeters of mercury of pressure here, and that's a whole other chemistry explanation how that works, that measurement. And then let's say that the volume of this cube is 2 liters. Okay. If I split, so this would be P1 is the first or the initial pressure. This is V1, the initial volume. Let's say that I have squished this cube down to 1 liter. Well, what's going to happen to the pressure, do you think? Can you do that math in your head? We have half the space to float around in. What do you think it's going to do to the pressure? It'll increase. By how much? Some of you are probably thinking it'll be increased by a factor of 2. That's a good guess. Now let's see if that's right. We can use the math now. So what you want to do here is you want to solve. We're looking for P1, right? So do you guys know how to solve algebraically for P1? What do you have to do? So what do I do to solve for P1 mathematically? What do you guys say? Get it by itself by dividing by V1, right? Because just like the factor label method, doesn't that cancel that out? It does, you know that, right? So maybe this sheds some light on the whole factor label method thing too. But this is equals which means one side is the same as the other. So if you're going to do something on one side, you have to do it to the other to maintain that equality. Right? So I have to also divide this side by V1. So now I come up with a new formula, or a new way to write this same formula. It's P2 V2 over V1. Okay. Now if we put in the numbers, P2 is, oh, I messed up here with my letters. I messed up with the variables. I mislabeled them in the beginning. This is actually V2, and this is P2. And so this is V1 and P1 here. So now we can fill in our numbers. P2 here is 760, and V2 is 2. And we divide that by V1, and you can see, just as Waldo said, it's increased by a factor of 2, which is 1520 millimeters of mercury. And that's the answer. Okay? You have questions about that? Okay, here's another situation for you. I have pressure 1 here of 2,380 millimeters of mercury and there's 3 liters volume to this gas. Okay, so without any exchange of gases, no gas going in, no gas going out, I change the volume here until I get a pressure that is 760 millimeters of mercury. Now, you could believe the picture by saying, oh, the volume is bigger, but really you should think about it. If I'm decreasing my pressure, what's going to happen to the volume? Well, when you can think about it, because there's particles moving around the box. It should be getting bigger, right? Because that means there's more space for it to move across until it actually hits something. Okay, so I want somebody else to come up here and use the formula to solve for our unknown variable, which is V2. Okay, I'll write this up. The formula for Boyle's law is always P1 V1 equals P2 V2. But I want someone to work this around algebraically. Yes, that's the correct form of that equation, Elijah. Thank you very much for coming up. So does someone want to come in and plug in the numbers? Matt. Okay. Okay, so thanks, Matt. So Matt came up here and plugged in the numbers. So P1 is 23,000 or 2,380. V1 is 3, and P2 is 760. So you go in your calculator. 2,380 times 3 divided by 760 equals 9.395. Do you have any questions about that? We're going to rehash the power or the pressure formula. So we've done this before, but pressure is force per area. And force is measured in newtons. Area is measured in like meters squared or centimeters squared or anything squared like that. And remember, pressure, we said, is measured in pascals, or like today we use millimeters of mercury. So number 1 says a book is sitting on a desk. The area of contact between the book and the desk is 0.7 meters squared. Okay? So we're looking for the pressure. So the 0.7 meters is the area, right? Or the 0.07. So 0.07 is the number you put in for area. The book weighs 37 newtons. Yeah, so 37 newtons is how much force that the book is applying to the table. So 37 newtons. And so we can figure out our pressure is 37 divided by 0.07, or the answer is 528.57 pascals. So, yeah, if you go back to where we were talking about pressure, we said pressure was newtons per meter squared or pascals.